So you're probably wondering why I played the happy birthday song, and I promise there was a point to it. Okay, we're going to use something called the birthday cake method later in this video lesson. Today we're going to talk about those rational exponents a little bit more. Those were those fraction exponents that we had from the last chapter or last section, and we're going to talk a little bit more about those nth roots, like the cubed roots and the fourth roots and all that fun stuff. All right, so the first part of this lesson is going to deal with kind of a review from algebra. We're going to talk about the different properties that exponents have, because after all, we've been dealing with fraction exponents. So one thing you might remember from Algebra 1 is the multiplication rule with exponents. When we have the same base, notice how this base is an A and the other one is an A. What we can do is when we happen to be multiplying them together, we can add the powers on the outsides to combine our two bases together. So I kind of have an example here. Sometimes it's better to look at an example than with letters. So let's use some of those fraction exponents we've been talking about. If I take 5 to the half times 5 to the 3 halves, notice how the bases are the same. Okay, so that base is a 5 and this base is a 5. Since I'm multiplying those bases together, I can combine them by adding the powers. So I can take 1/2 and add it to 3 halves. So I'm taking the first power and adding it to the second power. So adding fractions, make sure they have a common denominator, and these do, so we can keep that. And the numerators, 1 plus 3 gives me 4. But we can simplify 4 over 2 as just 2. So I can combine these bases together, the 5 and the 5, to be an overall base of 5, but with a new power of 2. Okay, so we're combining the bases with a new power by adding the exponents together. Now we can figure this out. 5 to the 2 is 5 times 5, or just 25. Okay, so some of you might remember doing this in Algebra 1. In Algebra 1, you used whole numbers, but since we've been talking about fractions as exponents, the same rules apply. We just got to be careful and we remember how to add and subtract, multiply, do all that stuff with fractions. All right, so let's check out the next one. This one you might remember also. If we have a power to a power, notice how we have a power of m being raised to a power of n. What we can do is, in this case, multiply them together. So when we're multiplying bases, okay, we add the powers. But if we are raising a power to a power, this is when we multiply the powers. Notice how there's a difference here. In this one, we added the powers. In this one, we're multiplying them. So in our example, we have a base of 3 to the 5 halves, and we're raising it all to the power of 2. So notice how I have a power of 5 over 2 being raised to another power of 2. That's what we call a power to a power. So I can multiply the powers together. I can take 5 over 2, my first power, times 2, my second power. And maybe I can convert this 2 into a fraction, because we're, after all, dealing with fractions. We multiply fractions going straight across, so I end up with 10 over 2, which is 5. So I can simplify this by keeping my base. Okay, after all, my base is 3, just like we kept this base of 5. And my new power is 5, since I multiplied my powers together. Now, 3 to the 5th, we can figure out what that is. It happens to be 243. Right, so there's that one. Next one we're going to talk about is a product to a power. So instead of just having one base, okay, sometimes we can have 2. And most of us, I think, are going to like this one because we like the distribution method. We're going to distribute the power to both of those bases. So notice how the A is now raised to the m and the B is now raised to the m. Okay, so let's take a look at an example. I have two bases. I have a 16 and a 9 being multiplied together. That's really important about this. Notice how it says a product. We have to be multiplying them together. If this said 16 plus 9, we would not be able to do this. Okay, most of us are going to get that confused. It has to be a product. You have to be multiplying. So let's get that out of there. All right, so let's distribute our power. We can say we have 16 to the 1/2, And remember, we're multiplying, so we'll do a little multiply, and we have 9 to the 1/2. Okay, we're distributing the power. But in the last lesson, we talked about converting rational exponents, these fractions, into radicals. And if we have something raised to the 1/2, that means we have a square root. It has a power of 2, and we only have one of them. So I can rewrite 16 to the 1/2 as the square root of 16. And likewise, I can rewrite 9 to the 1/2 as the square root of 9. Now this makes it really simple to simplify because we know what the square root of 16 is. It happens to be 4, and the square root of 9 is 3. So if I take 4 times 3, I get an answer of 12. So even though it looks complicated at the beginning, notice how simple our answer might get. All right, our next one, everyone's favorite, we're dealing with negative exponents. If we have a base raised to a negative power, a negative m, we can turn this negative exponent into a positive exponent by flipping the base. In other words, finding the reciprocal. So if we have a to the negative m, we can think about that as over 1. What I can do is make this negative power positive by flipping my 1 over a, and this negative m now becomes a positive m. Notice how it's still attached to the a base. Okay, so that's where this is coming from. Now you could go the other way. Okay, you could take a negative power in the bottom, but notice when you flip it, okay, the a's up top and now the 1's on the bottom, so the m changed from a negative m to a positive m since you flipped it. Okay, so this one is where most of us, I think, are going to get really confused, but let's just try to keep this straight. Okay, so in my example, I have 36 to the negative 1/2. What I can do is turn this into a fraction, and I know to turn this negative power into a positive, I need to flip my base. So I end up with 1 over 36, and my 1/2 becomes a positive. Now, just like our last example, we can convert this 1/2 into a square root. So I have the square root of 36, and I know the square root of 36 is just 6. So we have a final answer of 1 over 6. All right, let's check out a few more before we dive into some other examples. Another product or another rule of exponents that we have is something called the quotient rule, and we know quotients are normally dealing with fractions. So, I mean, if you want to, you can rewrite this just so it looks a little bit better. Okay, I can't really write it like this on my computer, but if we have the same base, okay, the same number or variable in this case, what we can do is combine those bases together since we're dealing with a fraction, and this time subtract the powers. And a little key here, we always want to try to use the largest one first. So maybe in this case, the m is the bigger one. We can subtract m minus n and keep the same base. Okay, so if we look at an example, notice how we have the same base, the same base of 4. What we can do is subtract the powers, but we want to pick the largest one first. And between 5 over 2 and 1 over 2, 5 over 2 is the larger one. Okay, so we're going to take 5 over 2 and subtract 1 over 2. Since they have the common denominator, we can keep that. And the numerator, 5 minus 1, gives us 4. But 4 over 2 is just 2. So since I subtracted the powers, I can keep my base of 4 because it was the same. And my new power is 2. But 2 squared just gives me 16. Hopefully we remember most of these. All right, the last one, we have a quotient to a power. Okay, if I go back for a second, we had a product to a power. Remember, that's when you're multiplying two things together. But a quotient to a power is when you're dividing two things together. So if we look at this, we can have a over b to the m. And just like we did for a product to a power when we distributed that power to both bases, same thing's going to go on here. We're going to distribute the m to the top base and the m to the bottom base. So both bases are now going to be raised to the power of m. If we look over here, I can distribute the 1/3 to the 27. So I have 27 to the 1/3. And I can distribute the 1/3 to the 64. I can have 64 to the 1/3. Now, to help us simplify this a little bit further, let's convert this to a radical. Since our denominator is 3, that means we have a cubed root of 27, and on the bottom we would have a cube root of 64. So if we think about this, what number to the third power can give me 27? That answer would be 3. And what number to the third power could give me 64? That answer would be 4. Okay, so that one happens to simplify to 3 over 4. If we check out our last one, it's not really a property, but it's just something nice to know. We know combining like terms, just like we had for square roots, they had to be like terms, they had to be like radicals. But since we're dealing with exponents in this case, we want them to have the same base and the same power. Just like for radicals, they wanted to have the same inside number, we want the same base and the same power. So notice in this one we have a base of y, and in this one a base of y, and we also have a power of a half and a power of a half. So these are what we would call like terms. Same base, same power. We can combine the numbers out front. And 2, -5 would give us a -3, and we keep the like term y to the 1/2. So very similar to the combining like terms with radicals or combining like terms like we normally would do, like 3x plus 4x. Notice how the bases are the same, okay, the powers are the same, so we can add the outside numbers and keep that like term. Okay, same thing going on here, but just with a fraction as a power. All right, so let's take a look at some examples. Our first one, we have 11 to the 2/5 divided by 11 to the 4/5. Since our bases are the same, we can subtract the powers, and we always want to try to pick the largest power to go first. And between the 2/5 and the 4/5, the 4/5 is the larger number. So let's take 4/5 minus 2/5. Since we're subtracting fractions, our denominators are the same, which helps, so we can keep the 5. And for the numerators, 4 minus 2 gives us 2. All right, so I know I can keep my base, 11. My new overall power is 2/5, but we got to be careful because since this 4/5 was the larger exponent, the denominator is where this final answer must be. So since the 4/5 was the larger one, that's where my overall answer goes. It has to stay in the denominator. And to keep it in the denominator, we can just put an understood 1 up top. All right, so there's that one. If we take a look at number 2, let's focus on the numerator first. We have 49 to the 1/5 times 49 to the 3/5. Notice how we have the same base. So since we are multiplying the bases, we can add the powers together. So let's take 1/5 plus 3/5, and we get 4/5. All right, so my new numerator, we can keep the base of 49, and I have an overall power of 4/5. I didn't really do anything to the denominator, so that will stay the way it is. All right, so we still have a fraction going on, but over here, we did 4/5 minus 2/5. Okay, we subtracted the powers. We might be able to do something like that here, but we got to be careful because the only way we can subtract these powers is if our bases are the same. And notice over here, 11 and 11, okay, that kind of worked out, but 49 is not the same as 7. Okay, so we cannot subtract the powers the way they are right now. This is when we're going to be a little tricky. We're going to be a little strategic on how we simplify this. Is there a way that I can turn 49 into a base of 7? This is when it's going to get tricky. I can rewrite 49 as 7 squared. After all, 7 squared, 7 times 7 is 49. So all I'm doing right here is rewriting this bigger base. I can turn 47 into 7 squared because they mean the same thing. But I still have a power of 4/5. All right, and I still have the denominator of 7 to the 1/5. Now notice how we're starting to get somewhere, okay? Our bases are starting to look the same, just like we had the 11s over here. Now, before we go ahead and subtract these, notice how we have a power of 2 raised to a power of 4/5. So if we have a power to a power, this is where we can multiply the powers together. I can take 2 times 4/5. Now, since we're dealing with fractions, let's turn 2 into a fraction. Multiplying fractions, we go straight across, so I end up with 8/5. Okay, so now my numerator is 7 to the 8/5, and my denominator is 7 to the 1/5. Now that our bases are the same, okay, we went from a 49 to a 7 by rewriting 49 somehow. Our bases are the same, 7 and 7, so that means I can subtract these powers, and we want to pick the bigger one first. So let's do 8/5 minus 1/5, which gives us 7/5. So since my 8/5 was in the numerator in the top, I can keep my base of 7, and its overall power is 7/5. Now you could write this over 1 if you wanted to, but that is really not necessary. So since our larger exponent was in the top, our overall answer remains in the top. Notice over here our larger exponent was in the bottom, so our overall answer has to remain in the bottom. All right, let's check out some more. All right, this is when it gets good. First thing I notice is that I have a negative power, and we cannot have negative exponents. We said that we can change a negative exponent into a positive one by flipping it. So what I can do is take this y to the negative 1/3 and flip it or move it to the numerator. So let's do that. Let's just write out that first step. Everything else is going to stay the same. All we're doing is moving this y to the negative 1/3. So I'll keep the x to the 2/5. I'll keep my y to the first. I'm moving up this y to the negative 1/3, and since I'm moving it, the power now becomes positive. And now the only thing I have left on the bottom is an x. Okay, so all I did is I moved that up to the top, which switches the power to a positive. Now let's try to simplify some stuff. I notice I have a y to the first times a y to the 1/3. So since my bases are the same and I'm multiplying the bases together, I can add the powers. So let's take 1 plus 1/3. In order to add fractions, the denominators have to be the same. So I'll put my 1 over 1, and I got to multiply the first fraction by 3. So I have 3 over 3 plus 1 over 3, which gives me an overall fraction of 4 over 3. Okay, so my simplified version getting there, the y's can combine together to a y to the 4/3, still over x. All right, now let's check out the x's, because notice I have an x up top and I'm dividing it by an x on the bottom. Those bases are the same, so if my bases are the same, I can subtract the powers. Now, since it's just an x, I just have a power of 1, so I can take the bigger power, which is 1, and subtract my other power, 2 over 5. And just like up here, we got to get a common denominator, so let's multiply this one by 5. So we have 5 over 5 minus 2 over 5, which gives us 3 over 5. And remember, since our bigger power was in the denominator, that's where that answer remains. So I need an x to the 3/5 in the denominator in the bottom, but I still have the y to the 4/3 up top. And there's nothing else we can do, because notice how our bases are not the same anymore. This is a y, this is an x. There's no way we can combine those together. All right, let's take a look at this last one. We have 4x to the 2/3 plus 5x to the 2/3. Notice how the bases are the same, x and x, but also the powers are the same, the 2/3 and the 2/3. So if we have same base and same power, those are like terms. What we can do is add the numbers out front. So 4 plus 5 gives us 9, and we can keep that like term x to the 2/3. Alright, so this video is getting kind of long. What I'm going to do is break up this section into 2 separate sections, alright, 2 separate videos. So this is all you have to do for tonight. Okay, for tomorrow we're going to do a little bit more practice with these exponents, and later down the road, maybe the next day or so, we'll watch the second part of the video. I mean, you can check it out right now if you want to. I mean, go for it. I'm not going to stop you. But tomorrow we'll do more with these exponents, and we'll talk about the square roots and why I played that birthday cake song in the next video. All right, so cutting it short today.